Welcome back, everybody. This is a video on the PDF or the probability density function of a continuous variable x. The PDF of x is the function small f of x, which is defined to be the derivative of the CDF of x. And since the CDF function is a non-decreasing function, from calculus we know that its derivative, small f of x, would have to be non-negative. So the PDF small f of x is non-negative, and it is the derivative of the CDF function. Now, because it's the derivative of the CDF function, we can say that the small f of x is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. And so this limit would be the same as the limit as delta x goes to 0 from the right. And so the numerator, I'm rewriting that. So the first term here in the numerator is the probability that x is less than or equal to x plus delta x, and the second one is the probability that x is less than or equal to x. So when you subtract, you get the probability that x is in between x and x plus delta x. So if you look at this limit, you see that the one way to interpret this PDF function is that it is the probability per unit length. So the probability per unit per unit change in x. So when delta x is very small, you can see that this fraction would be about the same as the PDF, and so I can say that the probability that x is in between x and x plus delta x is approximately f of x times delta x. So this is one way of interpreting the PDF function. So the one way I say this is that the PDF function f of x tells us the probability that x is near x. Alright, so in the next video we'll see the connection between the CDF and the PDF. See you then.